Welcome back, everyone. Thank you so much for sticking with this derivative operator series. And as promised, I will solve three example right now. And yeah, and then after that, I will come back to some properties, and then I think that should be it for our derivative integral series. So let's solve some example, okay? So the first example we're gonna solve is find a general solution for this equation y double prime plus okay minus 3 y prime plus 2y equal e to the power 4x. Okay, how are you gonna do that? Well, you have to the first step is you convert to operators. Okay, so what is y prime? Y double prime is d, y is d square y, right? You agree with me? Okay, y is y prime. Y prime is dy, and 2y you just keep 2. Okay, equal to e to the power 4x. Okay, so the convention is that y prime you write y, y double prime you write d square y. Okay, all that stuff. Okay, depend on the power derivative. Okay, so now you're gonna factor out. You get d squared minus 3d plus 2 y equal e to the power 4x. Okay, and then you factor this. This one you can factor. So this is d minus 1, d minus 2, y equal e to the power 4x. Okay, now how are you gonna solve this? Okay, this is very interesting. You're gonna say let d minus 2 y equal z. Okay, so y and z is both a function of x. Okay, in this case I'm gonna assume that y is a function of x. Okay, oh, y have to be, I mean, we're doing single variables right now, so okay, every function is a function of x. Okay, so so you rewrite equation 1. This is called 1. You rewrite 1. What will you get? You get d minus 1 z equal e to the power 4x. Now this is the fun part. Let me write that for you. Okay, now we're gonna apply one of the most very powerful formula we have. Okay, the formula say that d minus a equal to the power n equal to e ax d e to the negative x. Okay, power n. Okay, what does it mean? It means that and be careful, like it doesn't have to be y. It can be z, it can be g, it can be h, any function. Okay, this is just operator. Operator is like a machine. You throw in the function is your input. Okay, now we're gonna apply this theorem, very powerful theorem right here. Okay, with n equal 1. So what do we have? We have e to the power 1x times d e to the power of negative 1x times z. Oh no, there's no z, but you guys understand it, right? Remember z over here. Okay, equal e to the power 4x. Okay, you divide both sides by e to the power 1x, so d z equal to e to the power 3x. Okay, what you're gonna do next is that you write like this. You rewrite in normal form d dx of e to the power 1x times z equal e to the power 3x. Okay, so you integrate both sides. It will equal to this e to the power 3x over 3 plus c1. Okay, so what is z equal to? You time both sides by you time both sides by e to the power 1x here, 1x. Okay, you got z equal to e to the power 4x over 3 plus c1 e to the power 1x. Alright, you got z. Now let's start y. Okay, recall that this y. What I said, we said y too. So recall that d minus 2 y equals z. So what do we have? We have d minus 2 y equal e to the power 4x over 3 plus c1 e to the power x. 1x is x. Okay, so I'm gonna rewrite this in, I'm gonna use the powerful formula again with n equal 1, a equal 2. So let me write, if you guys don't know, n equal 1, a equal 2. So this will become e to the power 2x d negative 2x y equal e to the power 4x over 3 plus c1 ex. Okay, divide e to the power 2x both sides. You have d 2x of y applied to y equal to e to the power 2x over 3 plus c1 e to the power negative x. Okay, so you rewrite this in normal form. Like this, equal to 2x over 3 plus c1 about negative x. Okay, you integrate both sides. This become e to the power 2x times y. This become e to the power 2x divided by 2. And then you divide by 3 again. You get 6. Okay, plus c1 e negative x over negative 1 plus c2. Okay, be careful. Now I'm gonna turn this into c1 because remember, c1 over negative 1 is a number. You represent a number. So instead of writing this, I just need to write c1. You understand? Because it on every way, every symbol represent a number. So I'm just gonna write the most simple way, c1. I don't have to write c1 times 5, c1 to the power 4, square root of c1 or any c1. I just need to write c1. Okay, c1 it means a number. Okay, a random number. Okay, rewrite e power 2x times y equal e power 2x over 6 plus c1 e power negative x plus c2. You time both sides by power 2x. Okay, what do you get? You get this. You get y equal power 4x over 6 plus c1 e to the power x plus c2 e to the power 2x. Okay, yeah, this, and ladies and gentlemen, that is our answer for this problem. That is our general solution. Let me highlight in maybe red. Okay, this is the general solution for the first problem. Now the key point, the key takeaway is you set a function equals z. You set the, okay, you read from right to left. Okay, you read one from right to left. Let me read from right to left. Okay, and that's why I set this thing first equals z, and then yeah, you that's why I just met one of my friend, right? And I told them, hey, that there's a way to solve differential equation by just integrating back, integrate back. And this is that way I told you, derivative operators. You set equals z, and then you just keep integrating back. Okay, let's do our second example. What's our second example? Y double prime minus 4y prime plus 4y equal e to the power 4x. Okay, how are you gonna do this? At first, you rewrite in term denominator, derivative operators form. Alright, like this. Okay, plus 4 equal e to the power 4x. Okay, then you factor out. Oh shoot, I forgot. Y right here. Think about it like d square y's mean like any function y come to d square, come to d square, and d square is just gonna take the derivative of it 2 times. It's like a machine. So you factor out d plus 4 y equal to e to the power 4x. Alright, then what's this guy? This is a complete square, a beautiful complete square. Y equal e to the power 4x. Okay, now we're gonna use a very powerful formula. N equal 2. This is n. Okay, and a equal 2. It's 8. Okay, what do we have? We have, I'm gonna turn all of this into it will become e to the power of negative 2x times d square. Oh shoot, sorry. E to the power of 2x d square y d square. Sorry. Be careful. 2x y equal e to the power 4x. Okay, this is, I'm using this formula right here. Let me call this star. I'm using star. Okay, I'm using star. Okay, now, okay, I'm gonna divide to e to the power 2x both sides. I got d square about 2x y equal to e to the power 2x. And I'm gonna write normal form. Normal form means that d square means you take the derivative 2 times with respect to x of this function. Okay, equal to 2x. Okay, the first okay, now you're just gonna integrate the first integration. You know, the left hand side u dx. You agree with me? The right hand side u e to the power 2x over 2 plus c1. All right, second integration. The left hand side u e to the power 2x times y. Apparently, the right hand side u e to the power 2x divide by 2, and then because you only divide by 2, so divide by 4 plus c1x plus c2, right? So you time both sides by e to the power 2x here, and then all this time e to the power 2x. What will it get you? It get you y equal e to the power 4x over 4. Oh yeah, plus c1 e to the power 2x times x plus c2 e to the power 2x. Okay, ladies and gentlemen, this is our answer for the second problem. Okay, all right, very good. Now let's do a special problem. Okay. Example 3. Okay, now I'm gonna be a little bit abstract, okay, and then I'll explain you guys where. I'm just want to foreshadowing y'all to a next video. Now, what I'm gonna do is I'm gonna be like this. So solve this equation. So y equals 0. Okay, so what's u? U is a number. It's a real number. Okay. So if you rewrite in you know, denominator form, plus you square y equals 0. So you have what, d square plus u square y equals 0. Okay, you're okay. Now it's kind of weird, right? Because d square plus u square y equals 0, you know, it's gonna stem a we haven't do this before, right? Okay, I'm gonna stop the video here. You guys could think about it for a second. I'll see you guys in the next video, and I'll tell you a trick to solve, you know, this. I'll call this equation 2. Okay, yeah, I'm gonna teach you how to solve equation 2. Thank you for your attention.